Okay, we're going to talk a little bit about doing a multiple regression within Microsoft Excel. The reason why I want to do this video is because there are a lot of advanced statistical programs out there, SPSS, R, SAS, etc., that really are very, very powerful when it comes to statistics and other kinds of analysis. But you really can do quite a bit in Excel, and hopefully I'll be able to demonstrate with you that as long as you have your data in a pretty good shape and it's clean and you know what you're looking at, you can really do quite a bit in Excel. And a multiple regression is one of the most helpful types of analyses that we can do within Excel and in HR analytics. In this particular example, I'm using data about sales and salespeople. And so you can see the employee number over here on the left-hand side. You can see tenure, so that's how many years of experience that people have at the place of employment. We have their age, the territory that they sell in. You can see that's a range from 0 to 10. The number of sales trainings that they have attended. You can see some variation of numbers here. Their performance, which is on a 10-point scale, and then their total sales in millions, and this is annual sales. So you'll see some zeros in this column as well. That just means that they haven't yet reached $1 million in sales. Before we go into doing the multiple regression, if you don't have, or if you haven't added in the analysis tool pack within your Excel program, you'll need to do that. And I'll show you how to do that right now. You just go to File up at the top, and you go into Options, and down here towards the bottom is a menu called Add-ins. You click on that menu, and then it will give you all these different add-ins. This is called the Analysis Tool Pack. You click on that, and then you hit OK, and it will install that Analysis Tool Pack for you. And once you've done that, that Analysis Tool Pack and everything that it has within will show up on your Data menu. So if you click Data, you can see it says Data Analysis here, and it's a whole new section within the Analyze, or within the toolbar here. So that's the Data Analysis Tool Pack. And you can see all sorts of different types of analyses, ANOVAs, correlations, descriptives, et cetera, et cetera. Regression is in there, t-test, z-test. We're not going to cover all of those in this course or this book, but we will talk about some of these as we go. So it's helpful to have this downloaded. So let's go ahead and start to run. If we were, really the question we're trying to answer here is, does the number of sales trainings someone attends have an impact on the total sales that they generate, all other things held equal, or those things that we know about held equal? And again, you see the variables there at the top that I wanted to look into. So we're going to do a regression, but before we do a regression, one of the first things that we need to do is test for multi-collinearity, which is just a big word for, do we have independent variables that are correlated such that it gives us funny responses in our output. So we need to check our independent variables to make sure that they're not correlated too much with one another. What is too much? It really depends on the situation. We're not going to go into a whole lot of detail here, but we do want to make sure that we're checking for multi-collinearity. Now, you could do in those other programs like SPSS or SAS, you could do partial least squares regression or principal components analysis. Those are way advanced kind of statistical models that we're definitely not going to get into here. But if you do have an interest, those are two things that are easily searched for on the internet, and you can find all sorts of videos out there that talk about those types of analyses. But we're just going to do a simple multiple linear regression. And like I said, before we do that, we need to make sure that our variables are not too correlated. So we're going to click on this data analysis button. We're going to go to correlation, which is up here near the top. Click on correlation and OK. And we need to select our range. So we're going to select tenure. So I'm going to click on tenure and hit Shift and right arrow, and then Control Shift down arrow to select all of my data that I want to. Again, we're only selecting the independent variables. The dependent variable, the thing that we're trying to predict, is total sales. So click the down arrow. My data is grouped by columns. I have labels in the first row, and I want the Excel to put this in a new worksheet. So I'm going to hit OK. Now, this is a basic correlation table, and from your statistics class, I'm sure that you recognize this table. Ones all the way down because these variables are correlated perfectly with themselves. So tenure and tenure correlated at 1, age and age 1. So one thing that I will do sometimes, especially if I have a big correlation matrix, is I will delete these ones. And then I will highlight the data and go to conditional formatting, color scales, and then click on this first one, which means that the higher the value, the closer it gets to green. So it's basically a green, yellow, red. And so I'm looking for really high correlations, such as territory and tenure, which is correlated at 0.909, 0.91, basically, which is a very high correlation. You don't typically see those in the real world. So my decision now is, do I leave that variable in or do I take it out? I can choose either one to leave in or take out. In this case, I'm going to choose to take out territory. And you might ask, well, why would this happen? Why would these be, highly correlated? And it might be that, the longer someone works for a company, the better territory they have, or they get to pick, or whatever the case may be. But in this case, I'm going to choose to take out the variable of territory. So if we go to, and the others look just fine in terms of their correlations with one another. So if I go to, back to my data, I'm going to take out territory, and I'm just going to move this over to the side and kind of forget that it's there and delete that empty column. Now I'm ready to do our regression. So I will click again on data and data analysis, go down to regression, click here, say OK. It's asking for what is my Y input range, and that's the dependent variable. So total sales is our Y, Control Shift down, highlights that column, and hit the down arrow. Now it's asking for our input X range. So I'm going to highlight these other variables, tenure, age, number of sales training, and performance. Control Shift down to select those. It's asking, do I have labels here? Yes, I do. Our confidence level is 95%, and we want to put this in a new worksheet. And you can select other things like residuals and normal probability plots and things. We're going to leave those out for now. They're not important to what we're doing at the moment, so I'm going to leave those out. And we hit OK, and there we go. It's just as easy as that. That's our regression output. Now, let's talk a little bit about what's important and how we need to interpret our output. So first and foremost, we need to look at our R squared, which is 0.95, which is really quite high. And what R squared is, remember back to statistics class, R squared tells us that we are 95% sure, because we selected the 95% confidence interval, that 95.33% of the variance in total sales can be explained by the variance in the variables that we've included in our model. So again, the variance in total sales can be explained by the variance that we see in the model that we've put together, which is great. That's a really good thing. The standard error, we'll talk about that in a little bit. That's always the, you hear, especially among elections and things, plus or minus X%. That's what the standard error is there, and we'll use that in just a minute. The significance, we're going to drop down to the ANOVA table. The significance here is very, very low. So 2.56, et cetera, e to the negative 29th, which is very, very low, which means that our model is statistically significant. So that's really good. And then our coefficients, which are always important, and then the p-value is important as well. So our intercept, this is the constant that is in our model. You'll see that that is statistically significant. Tenure in years, the coefficient is 0.36, and the p-value here is very, very small, so it is statistically significant. The age and the p-value is not quite statistically significant, but you know, this is where we need to start to have these conversations and where kind of the value of having a discussion is really worthwhile. Number of sales trainings, you'll see not much impact here and not statistically significant, and then performance actually has a negative um, impact on sales. So let's talk a little bit about these coefficients. And the first thing that I want to note is that the coefficient is really the weight uh, of each of these variables in the prediction of our outcome variable. So when we go to predict someone's sales, we'll include these coefficients to be able to do that. When we think about, and I'll show you that in just a minute, when we think about um, the policy changes that we might make, or if we're trying to assess the um, the impact of a training program, this is really what tells us if the training program has an impact or not. And in this case, we can see that tenure has the biggest impact on sales because it has the biggest coefficient, has the biggest impact on sales compared to all of our other variables. Age has a very small impact. Um, Number of sales trainings really has no impact at all on our outcome variable, which is total number of sales. And performance is actually has a negative impact for some reason. And again, this is where we need to start those conversations with various stakeholders to talk about why might that be the case. So basically what I'm seeing in this model that we've put together is that the more tenure you have at this organization, the more you tend to sell. And that could be due to relationships that you're building with customers, or you're able to get things done within the organization because you know how work gets done, you know who to go to for certain things, etc. So tenure really has a dramatic impact on the dollar amount of sales that someone brings into the company. Now, what does this mean for our sales trainings? Well, if I were doing this analysis, I would want to go to the um, person who designed those sales trainings and talk to them about, you know, they don't necessarily make an impact as they are today, but you know, let's talk about how we can redesign those sales trainings so that they can make a bigger impact. Or let's take a look at some other data that we may have collected throughout the process that can help us to better understand what might be going on here. We're not saying let's scrap sales training altogether. We just need to have people who are with the company longer. That's not what we're suggesting at all. But we do need to start to talk about how do we diagnose even further kind of the sales trainings that people go through. And then performance, I'd also want to talk to someone about the performance management system and how that's working. There might be some sort of shadow performance rating that people are getting. So whether that be sales commissions or, you know, the top sellers get really big commissions, therefore, you know, managers within the sales function are trying to boost up the lower performers with better ratings or something. I don't know. We would need to dig more into that as well. But you can see from a pretty easy analysis in terms of technically how do you do it in Excel, it's pretty simple. We get a lot of information from from this analysis, and so it can be very powerful and very helpful in what we're trying to do. The final thing I want to show you is how we predict sales performance based on this model. And when we think about predictive analytics, oftentimes what we're talking about is regression modeling. So what I'm going to do is I'm going to copy and paste the first few um, uh, records here. So Control C, and I'm going to paste them just into this spreadsheet because it'll be easier to see what we're doing. I'm going to highlight these and double click to expand them. Whoop. Let's expand, change the width here. And so I'm going to add a column here that says predicted total sales. Um, Lower limit, this is where the standard error comes into play. Lower limit and upper limit. And so what we do is we basically create an equation for each of our participants. So predicted total sales is equal to our intercept, and we're going to lock that in place because as we copy this formula down, we're going to want that to stay constant. Plus, we're going to just multiply these things out. Our total tenure in years times the coefficient here. Again, we're going to lock that in place, F4. end parentheses plus parentheses age times age coefficient and parentheses plus number of sales trainings times coefficient plus performance times the performance coefficient. And we're going to hit enter. And you can see there that the answer is 7.387699. And now I need to go back and I need to lock in these other values so that when we copy it down, it doesn't go all crazy on us. So now we need to take into consideration the lower limit and the upper limit. And we're given that standard error right here, 0.74932. So we're going to say equals this, whatever number that is, and the lower limit would be minus this number. And we're going to lock that into place too because we're going to copy that down. And the upper limit equals this plus that standard error. I'm going to lock that into enter, and now we can calculate. If we just select and drag down, we're going to calculate the values. And you can see here, I'm going to take this number, actually I'm going to take all of these numbers and get rid of some of these decimal points. And so what we have here is the actual total sales was 8 million. Our predicted total sales was 7. But when we include the standard error, it said it's somewhere between 7 and 8. So that's exactly right. In this case, it was 2. We got somewhere between 1 and 3. So that was right on. This one was 0. They said it's somewhere between 0 and 1. That was exactly it. This one was 0. Said somewhere between -2 and 0. Spot on. This one was 3, so somewhere between 3 and 5. So even though these predicted sales may not have been exact, when you include the lower and upper limits, you get a really nice range and your values will fall within those typically. So super powerful stuff. We're talking about policy change. We're talking about predicting individual values. We're talking about all these interesting things that we can do with analytics. And again, we don't have to use the super advanced statistical software. This is nothing to be afraid of. We can do this all in Excel. And if you know how to interpret it, know what you're talking about, you can really do some powerful things. So I hope you learned something today. Thank you for listening to the video and talk soon. Thanks.